everyone. This is Professor DePaulo. Welcoming you back to Psych 265 Online. And today I'm going to be talking about the results in the methods section. So, for the results section, you don't have to do anything. I've taken care of the results for you, just because it's a little bit more complicated because it's statistics. And I've posted the results in the assignments tab on Blackboard. So if you go into the assignments tab on Blackboard, and I've put the results section here. And so let's look at the results section, what it means. So click on the results. It's a Word document. And basically what you want to do with the results for the final study is you want to copy and paste it. You don't have to do anything. Just copy and paste it and put it into your final paper submission at the end of the semester. But I want to explain what the results mean so it'll help you write your discussion section. So let's open up the results. So here's our results. And so looking at the results, I tested several of the hypotheses that I gave you. So let's go back and look at the hypotheses that I tested. So if you open up the instructions for writing the introduction, you'll see the purpose hypotheses that was stated in the last paragraph of the introduction. Our hypotheses are that females will multitask better than men, GPA will be positively correlated with multitasking, texting phone use will be positively correlated with multitasking, and age will be negatively correlated with multitasking. So I tested each of these hypotheses, and when you write the discussion, the first paragraph of that discussion will basically go through these hypotheses and state whether they've been supported or not. And so it's pretty basic once you do the results here, and I've done them for you. So let's go look at the results of these four hypotheses. So here's my results section again. There was a clear indication of multitasking decreasing cognitive performance. So basically what I'm saying here is that multitasking really slowed people down. It interfered with their ability to do the task that you guys did online. Participants who were asked to complete the two tasks simultaneously, and the online task here was categorizing both the shape of the stimulus and the number of circles, filled circles within those shapes, right? So basically what you saw during the task was either, a square or sort of a parallelogram, right? And you had to basically determine which, either the shape or the number of items inside the stimulus. Okay, so that was basically the stimulus. And in some cases, those two stimuli contradicted each other, right? So you needed to put opposite responses. So basically, what you would push for the shape would be different from what you would push for the number of items within the shape. And in some of those trials, they were similar. So what you would push, your response for the shape would be the same as your response for the number of items within the shape. And so when they contradicted each other, when the shape and the number led to two different responses, divergent responses, that would be multitasking. Because now you have to basically make a decision while doing these two tasks at once. And that should slow you down. And basically that's what we saw here is when the shape of the number didn't mix, participants were much slower to categorize, to make a decision on that task, on that stimulus. Versus when the shape and the number led to the same response, participants were much faster because they were congruent. So they didn't have to multitask. They didn't have to sort of make a decision between two competing stimuli. And the reaction times for trials that involved only the single task, where the response was the same between shape and number, was 595.75 milliseconds compared to 957.09 milliseconds for when the trials were opposite, so when the shape of the number resulted in different responses. And that slowed down things greatly. So it went from 595.75 in the non-multitasking part, and then in the multitasking part, it went to 957.09 milliseconds when you had the competing stimuli, right? Competing decisions to make. So that's a much smaller number, and that was significant. T of 31 is negative 9.639. P is less than 0.001. That's a significant difference. The p-value basically tells you what's the probability of getting this result by chance alone. So basically, what is the probability that this is a lucky result, that this is just due to chance, random error? And the p being less than 0.001 means there's a less than 0.001 probability. If you want to convert it to a percentage, you can multiply it by 100 here, right? But the probability is 0.001, less than that, that this is due to chance, and that's really, really small. That's less than 1 in 1,000, probably, percent chance that this is due to chance, right? This is a lucky result. So since this is less than 0.05, we basically say that this is a real effect. This is not due to chance because it's less than 0.05. That's the magic number that we use in statistics to decide what's a real effect versus what's a random chance effect, a lucky result. It's obviously more complicated than that, but since all of you guys didn't take statistics or are not interested in statistics, you're not going to want me talking about probability of type 1 error. But basically what it is a probability of a type 1 error, if you're familiar with that. And the probability of type 1 error is when you reject the null hypothesis, when the null hypothesis is in actuality true in the population. But that probably makes not much sense to you. So think of it as this is a lucky result. What's the probability of this being a lucky result, right? And it's 0.001, so that's really small. So therefore, we're going to say that it's not a lucky result. And instead, we're going to say that it's due to the effect of the independent variable, which in this case is multitasking. So the difference is not due to luck, but it's due to multitasking because p is less than 0.001, and the criteria we're using in most cases is 0.05. So I'm giving you kind of the gist of it, but not the technical, statistical driven. If you want to know more about type 1 error, type 2 error, probability, you can always email me or talk during my office hours, and I can go into more details from you and give you more literature to read. But basically, if you take a statistics course, that's what we'll talk about in more detail. And I am teaching a statistics course every fall. So in the fall, I'll be teaching it online, which is probably not ideal for statistics, but given the pandemic, kind of everything's been forced online. But I'll try to make it the best possible course that I can make it. So that's the first thing. So multitasking does interfere with performance. That's important to establish that there is a problem processing when you multitask. So now we're going to move on to more specific hypotheses here. So there was no gender difference in multitasking. Some of the literature indicates that women multitask better than men, although that's been controversial, that statement. We did not find that. Now, we have a small sample size. Our sample size is 32. We had 32 people in the sample, and we didn't find any difference between men and women. And I didn't look at the non-binary group because there's only one person in the non-binary group, and so we can't compare a group with only one person in it. So I just really compared men to women, and I couldn't really make a comparison with non-binary. But we see that there is no difference. F of 1.29, 1 comma 29 equals 1.040. Wilks lambda is 0.965. That probably doesn't make much sense to you, but these are parameters, these are statistics, I should say, technically, that are associated with the repeated measures ANOVA. And so the p-value here is 0.316. That is not less than 0.05, which is the magic number that we generally use in psychology. And so therefore we do not reject the null hypothesis, and we say that there is no gender difference. There's no difference in men and women in this situation in terms of their multitasking performance. And that's opposite what some of the literature states. And one weakness of the study here is the small sample size, 32. That's really small for a study. Now, obviously, I just collected data from my two classes in the summer, and we don't have many people in each class, 15, 16 people in each class. So that's why our sample size is small. If I was doing this as a regular study, I would want to have a large sample size, definitely over 100, 150, 200 people at least. If I was doing it online, I would want even more if possible. The bigger your sample, the better our results are going to approximate to the population, because a large sample generally is more representative of the population than a small sample. With a small sample, you can have outliers, which are data points that don't necessarily fit in with everybody else. So they're kind of like outcasts. I mean, we call them outliers. They're, what I call like misfit data points. They kind of don't go with everybody else. They don't go with the group. They're one of those friends that you have that they're just weird, and you really don't want to hang around with them too much. Your other friends don't like them. And so when you hang out with them, you kind of like hang out just the two of you, because you don't want to invite them into the group. Those are your outliers. If I have to break it down to like a personal level, right? Those outliers could be great, but they're not necessarily belonging with the other data, and they screw up your data with a small sample. So if you have a small sample and you have one or two outliers, like 32 is a small sample, those outliers can screw up your data. But if you have, say, 500 data points and you have a couple of outliers, they're not going to have as big an effect on your data, because you only have two compared to 500 versus two compared to, say, 32. So that's why the large samples are preferable. The large samples get you more statistical power, so you can actually more technically reject the null hypothesis much easier with a large sample, which is, in translation, it's easier to find what you want to find. It's easier to find the results of your study to support your hypotheses when you have a large sample compared to a small sample, because the large sample has more statistical power. And power is the probability of correctly rejecting the null hypothesis. So basically, if the result is true in the population, you're going to find that result in the sample if your study has adequate power. Technically, we want around 80% power. I didn't do a power analysis for this study. This is just a demonstration. But if I were to do a study, I would want that study to have a minimum of 80% power, which means basically I want there to be at least an 80% chance of finding a result in my study if the result really holds to the general population. So if your hypothesis is true in the general population, the entire population, I want to be able to show that my hypothesis is supported in my sample at least 80% of the time. That's, another more jargony, more technical, statistical thing. I'm not going to bog you down with that, but it's sort of how my brain works. And that's why I'm doing the statistics, because this would be very difficult for you to do. You might be able to do correlation, but I don't think you're going to be doing repeated measures, ANOVA, and stuff like that. So there's no gender difference. Men men did perform the single task trials about the same speed as women. So when they weren't multitasking, men and women were basically the same, 595 milliseconds to 592 milliseconds. But for the multitasking trials, men took an average of 1,024 milliseconds compared to women's 931. So you look at the numbers, and the men are taking longer, but once again, this difference between men and women in the multitasking trials could be due to chance, or what we call error variation or sampling error. It could just be that you just picked a particular few men and a particular few women, and by chance they're different, but in reality, in the population, there's no difference. You just happen to pick maybe some odd men or some odd women in this study. That's not to say any of you are odd, but I don't know how well a group of 32 people represent the entire population. If you were to do this study with 500 people, and you had a men showing men taking 1,024 milliseconds and women taking 931 milliseconds, you may find that result to be significantly different in a larger sample. So because our sample is small, that's a huge limitation of our study, is the small sample. Another limitation of our study is we just measured reaction times. We did not measure errors. So when you were doing the task, the system recorded your error rate. I didn't look at errors. I didn't ask for error rates. But it would be good to see errors along with the time to see if men and women make the same number of errors, or maybe men make more errors. So it's not just about how fast you make a decision, but it's also about how many mistakes you make. And we weren't looking at the errors or the mistakes made during the task. We just looked at the reaction times. So that's another limitation, is errors. We should gather that data. But once again, this is a pilot. This is a class study. If I was running this in the real world, I would really, increase the number of data that I'm looking at. I would kind of make the task more complicated, make the task longer, gather more data, gather more subjects. I would do all of that. But for a class thing, it's a pretty basic study, and just to get you kind of used to actually doing research, because this is real research. This study was designed based on another published study. The program that you used was based off of a study that was published, I think, in 2014. So this is real research. It just happens to be a very small sample, and I didn't throw in all the variables. I didn't measure everything that I could have measured. But errors would be something I would want to measure. That's a limitation also. So your limitations here so far are small sample size, which leads to low statistical power, and also we didn't measure errors. We just measured reaction time. Now let's look at the other hypotheses, which were correlations. GPA was not found to be significantly correlated with multitasking. So this correlation is almost zero. Obviously, that p-value is very high. It's not even remotely close to 0.05. So that means that this correlation is not statistically significant, which means it's basically not statistically different from zero. But you can kind of tell that just by looking at it. It's 0.002. Even eyeballing it, you would kind of say that that's not really different than zero. So there's no relationship here between GPA and multitasking ability. And the way I defined multitasking here was, your time differences between making the decisions when the number and the shapes are the same versus the situations where the numbers and the shapes were different. And I looked at the reaction time differences, and that was what I ran as the correlation of my definition of multitasking. That's kind of more technical, but GPA was not found with multitasking. That's the most important thing. There was no relationship here. Now, why could that be? I don't know. Maybe it's because everybody in our sample is trying to multitask, right? Some people more than others. And everybody's bad at multitasking. So it's not like, certain people are good at multitasking. And it's not like the people that are good at multitasking are necessarily better students. In general, the population is bad at multitasking. There are a small percentage, probably less than 10%, of the general population that is actually good at multitasking, or that can adequately multitask. Truly multitask, not task switch. So that doesn't mean going from one task to another task and going back to the first task. That's task switching. Multitasking means you're doing things simultaneously. And most people are not good at that. You know, I talked about my experience when I was working corporate, having to do the three things at once: being on a meeting, writing a report, having people talk to me, and have a meeting in my cubicle with somebody, being on a meeting on the phone, and then writing a report at the same time. And trying to do these three things at the same time is impossible. And I've already, explained that to my bosses. And I said, it just, but this is corporate America. And when I was working in corporate America, they were just like, we have to do this. They don't understand how the brain works. They don't understand how people can't multitask. All they understand is things have to be done, and you're going to do them. And if you don't do them, they'll find someone else to replace you. They're not interested in the literature, in how the brain works. You know, I had people ask me to do things in 10 minutes. Okay, write this report. When do you need the report? In 10 minutes. And I was like, this is going to take me 2 hours. No one could do this in 10 minutes. And I was told in 10 minutes. Well, guess what? I didn't finish in 10 minutes. And the reason I was told that these assignments, these reports are due in 10 minutes was because one of the vice presidents, it was a Friday afternoon, and one of the vice presidents was leaving for a vacation in the summer. And she wanted to leave. And she forgot that the report was due. And so she was leaving in 10 minutes, so the report was due in 10 minutes. This is another reason why I kind of wanted to get out of corporate, America. Um, you know, very unreasonable people. And no, I didn't finish it in 10 minutes. It took me over an hour. And I submitted it when it was done because it was impossible to do in 10 minutes. But, this is why corporate is about multitasking, about doing things that are kind of impossible. They just don't know, or they don't care, or both, right? So GPA was not correlated with multitasking. So the better students don't necessarily multitask better than the worst students. Age was also not significantly correlated with multitasking. Now, that kind of is a little bit more confusing because older people have generally been found to multitask at a lesser rate than younger people. But I think what's happening here is a lot of this is not multitasking. It's task switching. It's going from one task to another and then going back and forth, changing your attention. It's not really multitasking. So I think that older people cannot task switch as well. That's been shown in the literature, that they're slower when they go back and forth. They get off topic and you come back on topic and they don't know where they left off, right? As you get older, you can't switch back and forth as quickly as when you're younger. So I think there's something about that here. Also, text messaging was not significantly correlated with multitasking. So that's negative 0.053. So it has nothing to do with how many texts you send. Now, you might think, well, if you're texting and driving, you can't really multitask. You're going to have a problem with that. Yeah, you're going to have a problem. But once again, I think this is the number of text messages sent in a day. This is not like texting and driving. So, you have people that text and drive, they're not necessarily sending, so many messages. They may send a few messages. They happen to send them when they're driving because someone sends them a message and they want to get back to them. And so they figure, okay. I've had people tell me that they can text without looking at the screen on their phone, that it's just automatic. So if they're driving, they can watch the road and they can just text with their thumbs without even looking at the screen. And I'm just like, okay, sure. That's how you rationalize it. Um, you know, so the amount of text messages sent here is not correlated with multitasking ability. However, phone use was correlated with multitasking. So there we found a significant correlation here. So the more you're on the phone, um, the better you are at multitasking. Now that could be interesting because some people are on the phone all the time. So they're on the phone all the time. So they're just kind of used to being on the phone and doing something else. So you're on the phone and you're cooking, or you're on the phone and you're driving, or you're on your phone and you're doing their homework versus texting. And also, when you're texting, you have to actually look at the screen because I don't believe this thing that people can text blindly on their phone. You have to look at when I text, I have to look at my phone. I have to look at the screen. And if I don't look at the screen, I'm not even in the messaging app, right? I'll just be hitting random things on the screen. So with the talking on the phone though, we've been doing it all the time. It's become almost automatic, right? People have been talking on the phone for a long time while they're doing other things versus texting. Texting is a relatively new phenomenon. So I think people have practice talking on the phone. And I think talking on the phone requires less attention than texting. So it'd be possibly viable to multitask. Now, that doesn't mean it's good to talk on the phone and drive or talk on the phone and operate heavy machinery, right? That could be quite dangerous. But people talk on the phone, and it doesn't really require that many resources. Or when I was in corporate, I would talk on the phone and write the report, and I have a vague idea of what was going on in the phone, right? I wouldn't know all the details, but I can kind of like pick up the conversation by a few words here or there. Until they called my name and asked what I thought, and then they got my attention right away, and I responded something that I probably shouldn't have. Nevertheless, we're all used to talking on the phone, so it makes sense. You talk on the phone and you do other things, so maybe you've gotten better over your life by being on the phone so much and doing things. You've practiced. Or maybe just that the phone takes less attentional resources. I don't know. That's up to you to figure out. You're going to explain all this in the discussion section. So let me go to the discussion section. So the discussion section is also here on the assignments page, how to write the discussion section, right under the results section. So I opened it up already. Here's what your instructions are for the discussion section. Paragraph 1, restate your hypotheses and state whether you supported or failed to support your hypotheses. Well, if you look at our hypotheses again, we didn't support the first one. Females did not multitask better than men. We did not support the second one. GPA was not related to multitasking. We did support the phone use. We didn't support the text use, but we did support the phone use correlated with multitasking. And we did not support age will be negatively correlated with multitasking. So we supported 1 out of 4, which with 32 subjects is not that bad, to be honest with you. I mean, I've had, with 32, I can't expect, all these hypotheses to be supported. So with 1 of the 4, so you want to restate these hypotheses and tell me if you supported these hypotheses or you failed to support the hypotheses. Do not, state the results in non-statistical terms. So what do the results mean? So give me a little bit about, there's a correlation between phone use and multitasking. What does that mean in a non-statistical, technical way that I put in the results section? Remember that this first paragraph of your discussion section is kind of a summary of your findings, of your results section, without the statistics. Because a lot of people don't like looking at the results section because they can't understand the data, the statistics. So they skip right to the first paragraph of the discussion section, and they want you to figure out what the study found. So tell me, these are hypotheses we tested. This is what I failed to support. This is what I supported. And what does it mean? When I supported a hypothesis, what does it mean? So focus in on this correlation between phone use and multitasking. Tell me what it means. And if you can find literature supporting this, that's good too. Because that's going to be useful in paragraph 2 here. So in paragraph 2, how do your findings relate to past research, especially the research you did in your introduction? So you did the literature review for the introduction. You got a bunch of studies that were based on these variables in our class study. Tell me, are our results similar to past research, especially the ones you talked about in the introduction? Are they different? And if they're different, tell me why. Why are they different? So you might have found research on showing a correlation between or a difference between men and women in terms of multitasking. In our study, we didn't find that difference. So tell me why. Why do you think it's different? Why do you think something's similar to past research? Why do you think it's different? So that's in your second paragraph. Your third paragraph is kind of following up the second paragraph here in that if you fail to support your hypotheses, give me a reason. What were the limitations? I already talked about some of them. Small sample size, leading to low statistical power. What else? We didn't measure errors as a dependent variable. We didn't measure the error rate, which could show us something different. We measured reaction times, And, error rates could show us a difference that we didn't look at. What else could be wrong with the study? Was there something wrong with the multitasking experiment? I mean, is it a good way to measure multitasking? Is there a better way to measure multitasking? Go look in the literature. Think about this. Is if you were to do a study, would you measure multitasking the way that we did it as a class using a computer program? I don't know. What do you think? Tell me about it. Now, don't tell me about it with I or we. I don't like I, we, our, us, thing, yours. This is not really appropriate for a manuscript. So try to avoid that very casual language. It's not like we're not having a conversation. Like, well, I think the way you did this would be different than the way I did it. Well, that's a conversation, right? We have conversation, that's fine. But if you're writing a manuscript, you don't want to write, I would have done this. What you want to write is future studies could involve the use of this because it's been shown to be a better indicator of multitasking, right? There have been problems with, computer generated multitasking experiments. Maybe there have been, I don't know. Maybe look into that. See what you can find on it. I don't know. If you have other ideas, talk about them. This is your opportunity to be involved in how to interpret the research. It's not easy to write this, so I want you to think about it. Are there problems with internal or external validity? So, internal validity basically is cause and effect. So, can we draw cause and effect conclusions from this study? I don't know. Can we say that being on the phone causes you to be a better multitasker, or multitasking causes you to talk on the phone more? Can you say that? Yes or no? Remember, it's a correlation. What can you really say with correlation? Can you say cause and effect with correlation? There's problems, right? Think about the problems of that. External validity. Do these results, so that this external validity means, are the results generalizable? Can you generalize these results to the entire population? Well, I don't know. 32 people. College students. Age range 19 to 44. Can we generalize these results to the entire population of people in New York, in the US, in the world? I don't know. Is there a problem generalizing these results? So if we found that phone use is correlated with multitasking, can we go out and say, if you want to be a better multitasker, just start talking on the phone more? And we encourage everybody around the world to pick up the phone, talk as much as they can on the phone. Therefore, they can be more productive because they can multitask better. Is that the answer? Think about it. Do our results hold to the general population? Why or why not? That's paragraph 3. Paragraph 4. What are the real world implications of the study? That's kind of what I just said before about thinking about the uh, the meaning of this. You know, can we say with absolute certainty that there's no gender difference in multitasking? You know, these are things you have to think about. And more importantly than that, how would you address the limitations of the study? So there's a lot of limitations of the study. I've mentioned a few of them. If you can think of more, think of more. How would you address these limitations in future research? So basically, how would you follow up the study with a better study that can really address multitasking in a more efficient way and get us better conclusions? Maybe more generalizable, maybe better internal validity, better external validity. I want to see what you can think of. So I've given you some ideas here, but I also want you to go maybe research more articles, especially for paragraph 2. Are they similar to previous research? If you don't have that in your introduction, make sure you find articles that looked at this already and what they concluded and why you think our study is different from what they studied. And you got to really critically think about the problems with this experiment, doing the experiment online, doing it with a small number of people, maybe not including everything that should be included to measure Are we measuring multitasking the appropriate way or not? Do you think there's a better way to do it? This is not easy. As a researcher, as a student, obviously this is hard. I'm not gonna sugarcoat it. This is a hard assignment. Writing the discussion is hard. I think it's harder than writing the introduction. The introduction, you're basically talking about what's already been done. So you just have to research it. Here, you're really talking about what has been done and what you could do better. And that requires more critical thinking. So take some time to process this and give me 4 decent paragraphs, not like 1 sentence paragraphs, 4 thoughtful paragraphs about this discussion. And don't label them paragraph 1, 2, 3, and 4. Just write 4 paragraphs, double space, 12-point font. You could write 4 paragraphs in, more than a page, right? Page or 2 pages, maybe a little bit less. I don't know. Uh, 4 solid paragraphs as a discussion. And I don't expect it to be perfect, but I do expect you to put effort into it and to really think these things through. And I've given you suggestions again, and see where you go from there. But I wanted you to brainstorm some activities here um, about this. I mean, yeah, it's tough. It's a summer session. You don't have much time to turn these around, but I want you to devote some time to this. And if you have questions, you can let me know. I'll be happy to answer questions. But I think this gives you a sort of a basis of how to walk this through. So, once again, the results. If you go to assignments, the results section is posted here. The discussion instructions is posted below it. And you want to submit your discussion as a PDF file here, and you want to upload it by June 21st at 11:59 p.m. as a PDF. And then I will get to it and give you more feedback. So I think that's it. If you have any questions, let me know. If not, good luck with this. Good luck with the exam. And I'll see you next time for the title, abstract, and reference section. Bye for now.